All right, it's 11:02 Eastern, so let's get started. Thank you very much, everyone, for joining today. Hope you're staying safe. Hope you're staying healthy wherever you guys are in the world. Today, we're joined by Vinod Damla. He's one of our renowned senior protocol engineers at Kaleido. He's worked extensively with all of the major open source code bases, Geth, Quorum, Hyperledger Besu, and made substantial commits upstream to all those repositories. He also works very, very closely with a lot of our core customers, not only adding improvements into their infrastructure, but helping debug some of their critical issues. So very lucky to have him here today. In the past, on these Tech Tuesdays, we've focused a lot on a lot of the tangential services that either sit off-chain or accompany your blockchain infrastructure, stuff like enterprise integrations for identity, storage, key management, et cetera. Today, we're actually going to look solely at the blockchain protocol layer. Obviously, very, very important. That's your trust anchor, that's your ledger, that's your indelible source of truth, and a lot of really exciting things that are manifesting and maturing in the enterprise Ethereum space. So Vinod's going to go ahead and walk us through how to apply hard forks into your environment, into your blockchain, and pick up some of these new EIPs and protocol configurations that are available in the newer Ethereum variants. Just a few pieces of table setting and admin before we get rolling. I'm going to skip all of the slides that I typically use as a preamble and intro. If you guys are interested in a Kaleido 101 or just some introductory context, you can easily go look at all of the previous recordings on YouTube. Just search Kaleido Blockchain. All the Tech Tuesdays and Walkthrough Wednesdays are curated. And then tomorrow, Wednesday, the 29th at noon Eastern, I'm going to take everyone through Kaleido 101, and we'll look at a lot of the new improvements and new services that we have in Kaleido. One thing I just want to draw everyone's attention to super quickly here. We just released our product announcement notes for July. A lot of exciting things that have happened inside of the platform. I'm just going to do a quick walkthrough of these, and then I'm going to punt it over to Vinod. But just for some context on what's new in Kaleido, we added Paris as a new Azure region in France. So now you can run in US West, or you can run in Azure Europe, spanning multiple continents on Azure. Of course, we have all of our AWS regions. And then new support for essentially an easy button for Kaleido private stack or on-premise deployments. Hard forks, I won't spoil the surprise with that, but Vinod's going to touch on that. Brand new event streams in Kaleido. These are a really awesome feature where you can subscribe to smart contract methods, get those events, get those state changes that matter to your back office processes in your business, and you can get those reliably delivered directly into an application, into a serverless function, and the experience now in V2 on Kaleido is just really, really lovely. So I'd encourage everyone to check out the documentation. We'll also walk through that tomorrow. Multi-factor auth is available for your sign-ins, adding extra security. Google Login is now also available. Block signer, vote in, vote out. Vinod covered that 2 weeks ago, but also, very, very easy way to allow your network, your blockchain environment to scale and reconfigure dynamically. A lot of new updates on our billing dashboard, so you have a real easy, holistic oversight into sort of your forecasted billing and your current billing costs. New privacy models on Quorum, Tessera 10.5. The Ether pool inside of V2 of Kaleido is really, really easy to use and also very awesome. We're going to give you indexed balances for any account that Kaleido knows about. So that could be a node account, it could be a HD wallet, it could be an ETH wallet, it could be a Cloud HSM wallet. Also a lot of wallet updates, kind of just touched on those. And then a new partner service in our marketplace, IOCash, allowing you to very easily take your real world fiat currency, represent that on the blockchain, do all of the on-ramps and off-ramps as well. So a lot of exciting things. We'll touch on a good majority of these tomorrow during the Wednesday walkthrough, more Kaleido 101 focus. As I mentioned today, we have Vinod. He's going to talk about hard forks. So without further ado, we'll get into it and try to give everyone about 30 minutes back of the hour today. So I'm going to stop sharing and turn it over to Vinod, who once again, one of our lead senior protocol engineers at Kaleido.
Hi, everyone. Thank you for joining. So we'll be talking about hard forks today and how you can apply the latest protocol upgrades to your environment in Kaleido, if necessary. And I'll touch upon it in a moment as to how you would know whether you need to apply a hard fork and all the good details associated with that. So before we dive into the actual procedure of applying a hard fork, let's step back and take a look at what a fork is in the context of Ethereum, and also in the context of the public Ethereum mainnet, as well as the permissioned Ethereum network, which is relevant to your environments in Kaleido. So as most of you, or probably all of you, are aware, a blockchain network which is running Ethereum nodes consists of a set of clients which operate in concert with each other. They produce blocks on an ongoing basis. And what do these blocks contain? They mainly contain transactions which are submitted and processed by the individual nodes. Now, because one of the central tenets of blockchain network is supposed to be data consistency, you would expect that a block which is produced by any of the nodes in the network is equivalent, in the sense that a block which is produced by one node or another node can be accepted and processed by any other node in the network. And if a different node were to produce the same block with the same set of transactions, it would look equivalent in terms of all the contents for the transactions and the state. So given this assumption, there's bound to be a set of rules, or what is known as the protocol, which dictates how all these transactions are processed and assembled into the block. Now, over time, each client, which is the software that is running on the node, gets upgraded because there are newer client versions which has bug fixes, newer features, or even protocol enhancements. So there could be over time change in the protocol or the rules that govern the processing of transactions into blocks, which means that every client may be running different versions of the protocol. So in such an environment, how do we make sure that all the blocks which are produced by the different nodes in the network are equivalent and have been constructed with the same protocol version? So in order to do this, what Ethereum's architecture allows for is something called a chain configuration, which is basically a set of configuration parameters that says, there's protocol version Byzantium, there's protocol version Constantinople. And what does each of these protocol versions indicate? It basically indicates a block number at which that said protocol becomes effective. So that way, any node which starts with a particular chain configuration understands that at block number 0 or 10 or 15 or whatever be it, it has a certain set of protocol options which are in effect. So when a node is producing blocks, it has a reference point for a blueprint of what the protocol options are. And using those and using the block number which it is producing, it's able to produce a block with a state which is consistent with the rest of the nodes in the network. Now, how does this apply in the context of the main Ethereum network versus a permission chains? So both the permission chains and the Ethereum mainnet have a set of protocol options or the chain configuration. But because the Ethereum mainnet is a single network and any node which is part of the Ethereum mainnet is running with the same chain configuration, what happens is over time, the maintainers of the Ethereum mainnet can say that at a certain block, which is, I don't know, it could be 7 million, it could be 10 million, the future protocol version, which is Istanbul, for example, which has been introduced in Geth 1.9, becomes active. So any node which is running on the Ethereum mainnet can then apply the new chain configuration to its Genesis config, which is basically the chain configuration that gets encoded in the Genesis block, and use that as the blueprint for running the node. So because it's a single network, the block numbers are universal, so everyone has the same reference point in terms of block numbers and the time for which the network has been running. So permission nodes are slightly different because there are, literally thousands of networks which, Kaleido runs, for example. And each of these networks is started at different time, because of which there have been different number of blocks which is minted in each of these networks, because of which when you intend to apply a new chain configuration, we need to be aware of what the current block number is in the network into which we are applying the chain configuration. So using the current block number as the reference, we can then say, okay, maybe 100 blocks in the future or 500 blocks in the future, I'm going to introduce the next protocol version, which is Istanbul or Constantinople, depending on the protocol versions which are not currently present on the chain. So that's kind of how the concept of a fork or a hard fork is different between a permissioned or a private blockchain network versus the Ethereum mainnet. So I've basically gone over a bunch of concepts in the last 10 minutes or so. Anyone has any questions before I move on to a demo of how all of this works in Kaleido?
I think there's something in the Q&A, Vinod, that may be worth addressing initially.
Okay, let me take a look at the... Okay, so the first question says, what if nodes start with different Genesis forks? So the first thing to be aware of is for all the nodes to be part of the same network, they need to have the same Genesis configuration. So if nodes start with a different Genesis configuration, so say for example, one of the nodes has Byzantium block starting at block 0, but another node has Byzantium block starting at block 5, the initial handshake is going to fail because they look at each other. So basically, one of the first steps in a peer-to-peer communication on Ethereum is the nodes exchange their chain configuration. So when a node receives a handshake message from another node in the same network, it looks at the chain configuration to see whether things like the chain ID and the rest of the chain configuration match with what it is running by itself. And if they don't match, then the handshake fails and the nodes won't be able to talk to each other. So for a network to be operational, usually there's no chance that the Genesis config is different between the different nodes. So the next question is, can forks be changed after the node is up and running? Yes. For blocks in the future, typically that's how applying a hard fork works. So let's say we are at block 100 and we haven't applied, for example, the Constantinople hard fork. So the way the Constantinople hard fork at that point is applied is we pick a suitable block number in the future, depending on the individual network use case. And then we modify the Genesis configuration on all of the nodes together. And then we restart the nodes and instruct the nodes to go and reread the Genesis configuration, because now there's a new configurations item in the Genesis config. So after all the nodes reread the Genesis config and reload the configuration, they are then able to say that, hey, at block 150, for example, the new EIP or the chain configuration becomes effective. But what is not allowed is, so let's say you started the network with Byzantium block at 0. And if you try to later modify Byzantium block on a running chain, which has mined some blocks, to say, change the Byzantium block to 10 or 100 or whatever it is, then you will start seeing errors in terms of the blocks being mined, because now the rules are different in terms of at what block the Byzantium fork is active. And there's no consistent view between what's already on the chain in the chain database versus what a new node thinks the chain configuration is when it's trying to sync blocks. So basically what happens is when you add a new node to such a network where you changed the chain config after initialization, the new node thinks, so the new node has the latest view of the chain configuration, which says, for example, Byzantium block is at 10. But the blocks it receives from other nodes when it's syncing says that the Byzantium block was at block 0. So when it's trying to validate transactions, those validations fail because the rules are inconsistent now. Okay, so we have one more question, which says, can the fork be silenced in the future blocks after being activated in the old blocks? I'm not quite sure what this means. So when you say silenced in the future blocks, are you talking about like deprecating a feature, or are you saying I started the chain with a certain chain configuration and I want to remove that chain configuration in the future? If the question is about the latter, I'm not, okay. So if the fork is activated, can it be disabled again? Typically no, because once the fork is activated, then it means that that protocol is effective at that block number going forward. At least I have not come across an instance where a protocol is enabled first and then disabled in a later block. Trying to think again. Yeah, pretty sure. Haven't seen such an instance.
Awesome. Thanks for addressing those, Vinod. So we'll press on with the demo, and then we'll grab the Q&A or the chat as those come through. But let's do 5 to 10 minutes of the actual console here for a little bit.
Sure. So so let me close the questions tab. Okay. So what I've got here is 2 environments, and the reason why I have 2 environments is mainly because to save time. Once we apply the hard fork, typically you would have to wait for 10 minutes for that block in the future to arrive when the hard fork becomes active for the new protocol. So in order to save that time, I've got 2 environments, and I'll quickly go over the differences between the 2. So the first environment I have here is called hard fork demo. And you can see that the release version here is 1028. And specifically for environments in Kaleido which were created last year or before, we did not have the Constantinople block in the Genesis config. So for those environments, when you're at release 1028 or later, on your environment dashboard, if you navigate to the settings section, one of the sections now reflects what is called the fork upgrade, which indicates that you can apply a hard fork to the environment. And how do you know whether a hard fork is applicable to your environment or not? So we have a details section here that says a new EIP is available to be applied to this environment. And in this particular case, you see that the console is indicating that the Constantinople block can be applied to the environment. Now, I will go over another environment which I created this morning. And I've already applied hard fork to this environment, which I will be using in my demo shortly. But if you look at the settings for this environment, it is saying that the Constantinople block is active from block 282. So this is because I applied a hard fork this morning and the Constantinople block is already active. Now, if you have an environment which was created this year, then when you navigate to the settings under your environment, you will see that Constantinople block is already active from block 0. Because for newer environments, we set all of these options to start at block 0. So you have all the options available from the get-go. So if you created the environment this year, you will definitely not need to apply the hard fork. You can always go to the environment settings and check whether that's needed or not. But most environments which were created last year will need to apply the hard fork. Now, what's the process of applying the hard fork and what does it mean for your environment? There is a slight downtime when you apply the hard fork. because of what I said earlier, which is we need to apply the updated setting to all the nodes in the environment. We can't really perform a rolling upgrade, which is Kaleido's usual mechanism for upgrade, which means when we perform a hard fork on the environment, then all the nodes are brought down, and the Genesis configuration is updated and all the nodes are brought back up. So depending on the number of nodes in the environment, you will experience a downtime, which is basically in the range of from a minute to a few minutes. So this is definitely a planned maintenance action which you should perform when you don't anticipate your environment to be used by your end users or your end customers. So please be sure that this is a planned maintenance window. Now that said, so what I'm going to do is go back to the old environment here, and I'm going to demonstrate the application of the hard fork. Now, before I apply the hard fork, I'm also going to show via the API what the current chain configuration is and what I mean by Constantinople block is still not present in the chain configuration. So Kaleido's API, as you're aware, provides a mechanism to query the node status from any of the running nodes in the environment. So I've got here the path to the API request, which says consortia environment nodes followed by the node status. So let me refresh the request. So as you can see, there's a bunch of things which are returned by the API response. So one of which is, so you can see, here. So you can see that the chain configuration is returned by the node. So this is the active configuration which is in effect on chain on this particular node. So you can see here a bunch of EIPs or chain configuration elements. And in all of this, so we can see the Byzantium block being active from block 0, but we do not see the Constantinople block active. So the goal of applying this hard fork is to apply the Constantinople block. And what we will see is it becomes effective at a future block. So right now, if I refresh, we are at block 1851. So we will see that the Constantinople hard fork becomes applicable or effective at a future block, which is slightly higher than 1851. So I'm going to apply the hard fork, enter the confirmation text, and click on fork upgrade. So once I go back to the environment dashboard, you will see that all of the nodes are now in upgrading state, and none of these are actually in effect right now, or none of these are up right now. So while this is going on, I want to give a quick demo of smart contract which is using the Constantinople hard fork. The aim is for me to walk through the use of Constantinople block and one of the features which was introduced in the Constantinople block to demonstrate that this was this cannot be executed in the chain prior to the hard fork, and it becomes successful after the hard fork. So one of the things which was introduced in the Constantinople hard fork was support for a new opcode called ext code hash, which basically returns the hash of the code in your smart contract. Now this is used for things such as whitelisting smart contracts. There's a bunch of different applications which you can read about in the documentation for ext code hash. But basically what I'm going to do is, and this is a very simple contract, and all this is doing is accepting the address of an account and then it's running the ext code hash on the code for this account address. Now, the reason why this opcode was introduced is because it has a lower gas cost to run just the hash of the code, as opposed to getting the entire code from the smart contract. So I'll run this smart contract using our open source Kaleido Go tool, which is used for transaction submissions to the chain. And you will see how this errors, before the Constantinople hard fork is effective, and it works after the hard fork is successful. So if we go to the settings here, so you can see now that the hard fork is now applicable from block 1975. And let's make sure we are still at a block which is less than the 1975, which is true here. So I'm going to go to another window where I've got a Kaleido Go submission to this particular node. And let me make sure I've got the right node here. So it's 7v-myk. So it's 7v-myk. So I'm going to submit the contract and a transaction to this particular node. Let me open the view for the logs on this node. And so this submits a contract, which installs this Solidity code onto the node. And it executes a transaction using the code in the contract. Now you see that there were a bunch of transactions that get submitted here. And I'm going to look for an error message that indicates invalid opcode. So you can see here, I am trying to execute ext code hash opcode on this particular chain when the Constantinople block is not yet active. Now, because Constantinople block is not active, the Ethereum virtual machine is not aware of this particular opcode. And so you're seeing an error that says invalid opcode, and the VM returned the transaction with error. If we go to Kaleido Go, we can see that there's an out of gas error for these transactions. And this basically says the transaction execution failed. Now, I've also got the other environment, which I was showing earlier, on which the block number is currently 2200, and Constantinople block is active from block 282. So one of the other things I'll do before I run the transaction submission again is let's go and ask the node for the status again. So when we query the node status again, you can see that the live chain config is now reflecting that Constantinople block is active at block 1975. So this is now proof that the node has been updated. It has restarted with a new chain configuration that is applying Constantinople block at the said block number. So if I now go and query the node on this other environment, so let me replace just this portion of the API request. So I see that Constantinople block is already active from block 282, and the block height is currently 2000, which means definitely Constantinople is active on chain currently. So I'm going to apply the same smart contract to this next node. So I might have to, okay, so let me regenerate app creds. And I'm going to connect to this node. And the one thing I will have to do when submitting a transaction here is to change the account number or the account address, because the new node obviously has a different account, and I need to use the account address for the node I'm talking to now. So I'll copy the account address from this node. It's an extra character. And I will submit the same contract to a different, to this new node, which already has Constantinople block active. So I can monitor the logs here. And this is now saying I submitted the transaction. And you can see those transactions getting mined successfully on the chain. What will also, so you can see it was successfully mined, but for completeness, what I'm going to do is attach to the RPC console on this. Okay, so it looks like I was already on it, but let me attach to the RPC console and walk you through the execution of that transaction to show that the opcode was actually executed. So there's a RPC command that says I can get the transaction receipt for one of the transactions. So I can pick any transaction pretty much. So I'm going to pick the first one. So you can see the transaction was successful as the status indicates, and there's the transaction hash and the amount of gas which was used for the transaction. And I'll run a debug on this same transaction hash. And this is gory details. Most of you may not care about any of these opcodes, but if you want to peek under the hood and look at what's going on, you will see that there's this one particular operation in Solidity caused a bunch of opcodes to be executed, and one of them you will see is the ext code hash opcode. Scroll up. So this ran the ext code hash against the code for the address, the contract address, which I pointed to. And this is basically one of the features of Constantinople in action. So that was, again, a lot of detail. Any questions or comments?
Yeah, very, very cool to know. There's one in the Q&A, which
Okay.
I can grab and then leave it to you for more details.
Sure.
The question for all folks, what if I'm part of a consortium with tens of other members and tens of nodes? Who takes the upgrade decision? Every environment owner. So we sort of scope Kaleido environments into two different buckets. And it's around the orchestration of your consortium. So there's two models in Kaleido. You can have what we call a proxy operated business network or a consortium, where you essentially have one organization, a benevolent dictator, that's operating all of the resources, all of the nodes, all of the security credentials, services on behalf of external parties, folks that want to participate in the blockchain network, but don't necessarily want to be the root administrators or have that unilateral or autonomous control. In that circumstance, obviously, we only have one individual, our benevolent dictator or our network operator. The alternate route is to decentralize the ownership of your business network on Kaleido, and you start onboarding external entities. When you onboard external entities, the initiator or the founder of the consortium, operator number one, is able to extend those invitations and embed permissions inside of those onboarding invitations. And one of the permissions that can be allocated or rescinded is this permission called manage environments. And this obviously allows you to create environments, to delete environments, to upgrade environments, and to apply some of these new configurations that Vinod has walked you guys through. So in that scenario, any operator with that permission is going to be able to apply this hard fork upgrade. Anything you want to add there, Vinod, sort of on that on that process?
That's a excellent summary, Nick. Nothing more to add.
Okay, cool. Yeah, that was terribly interesting. Yeah, it was, I know a little bit of gory detail at the end, but kind of cool to peel a few layers of the onion back and actually see what's happening at the actual EVM layer in Solidity and all of the instructions that take place for, what is ostensibly, a very simple piece of Solidity code or smart contract operations. So pretty cool that Vinod was able to show us that. So I just want to wrap up with a few final things. As I said at the outset, tomorrow we're going to do Kaleido 101. We're going to walk through a lot of the new services, a lot of the new features and functionality on Kaleido. That should be useful for folks that are new to the platform and just want to see how a lot of these things are able to be stitched together. The second thing I want to touch on, if you are an enterprise or you are, in the R&D department or even a startup, and you're looking at, use cases that might involve supply chain or might involve the sharing of private documents or data in either a public context or in some sort of private obfuscation context. We do actually have some turnkey assets now that can really accelerate the life cycle of your project. So we do underpin every service in Kaleido with a very simple REST API. And we objectively feel that it's very easy to integrate and weave together all of our components, but you're still tasked with understanding those APIs and doing the full stack development and then layering a front end on top of it. So for folks that really just want a tangible asset out of the box, something that requires very little heavy lifting, very little configuration, I just want everyone to know that we do have a handful of these assets now, and we're happy to bundle those as part of a package for 3 months, 6 months, maybe even a year, to try to really, like I said, accelerate your journey on Kaleido and within your company as well. The last thing I'll touch on, this sort of goes hand in hand with what I was just saying there. Not only are we, standard software as a service model where you can do pay as you go for services and node runtimes, but we also have packages that can help you, whether you're in the proof of concept, pilot, MVP, or even production phase. And this is applicable to, centralized environments, decentralized environments, or somewhere in the middle. So if anyone wants more information about those, has any follow-up technical questions or commercial questions, happy to deal with those offline. And I'm going to share my email inside of the chat, just so everyone has access to that. And please don't hesitate to reach out to myself or just reach out to Kaleido in general, either through the support console inside of Kaleido or to me directly. So just wanted to touch on those two things. And again, we really thank everyone for attending. Down the road on Tech Tuesdays, we're definitely going to cover Kaleido Private Stack and show you how easy it is to actually stand up and operate and instantiate your node in your own private on-premise data center or on your own laptop. And then we'll start looking at a lot of the new partner services and marketplace additions that have come on board into Kaleido as well. So just a little roadmap sort of agenda of what's to come here on Tech Tuesdays and Walkthrough Wednesdays in Kaleido. And I think let me just make sure there's nothing left inside of the chat. We're good on the Q&A and inside of the chat, just a thank you. So I'll also extend one final thank you to all the attendees and especially to Vinod for walking us through that. And once again, please don't hesitate to reach out for any technical or commercial follow-ups. So
thanks everyone for attending. Thanks for your time.
We'll see everyone soon. Bye.